Page 608, number 59. Find the sum of the infinite geometric sequence. And we're looking for the sequence as n equals 0 up to infinity of 10 times 4/5 to the nth power. Okay, let's start by finding the first few terms. First of all, let's plug 0 in place of n. 4/5 to the 0 power, anything in the 0 power is equal to 1, times 10. So there's our first term. Plus, actually I should say there's yeah, it's our first term, but we plug 0 in place of n. To find our next term, we're going to plug 1 in place of n. So I have 10 times 4/5 to the first power. Well, 10 times 4/5, 4/5 of 10 is equal to 8. Plus, now we'll plug, let's see, we plugged 0, we plugged 1. Now let's plug 2 in here. If I plug 2 in place of n, I get 4/5 to the second, which is equal to 16 over 25 times 10. Let's get out our calculator to find that. So I have 10 times 4/5 to the second power. So that's going to be plus 6.4. I can find the next term by taking 10 times 4/5 to the third power. And that's going to be 5.12 plus etc., etc., etc. We're going to keep adding those up until we have an infinite number of terms. Okay, now how are we going to get a sum of an infinite number of terms? We can't possibly write them all down and add them, but we do have a formula to find the sum of an infinite number of terms, and it looks like this. The sum of those terms equals a sub 1, the first term, divided by 1 minus r. Now r is the common ratio, what we multiply by every time to get the next term. And I think you'll agree, both looking here and at this formula, we multiply each time by 4/5. So we have the previous term times 4/5 times 4/5. So to find that sum, we can take our first term, which is 10, over 1 minus that common ratio, which is 4/5. Well, 1 minus 4/5 equals 1/5, so I have 10 over 1/5. And if we multiply top and bottom of this fraction by 5, we get the sum of this infinite sequence is equal to 50. So if I could possibly write an infinite number of terms, add them all together, these will all add up to 50.